Hello guys, in this video we'll try to discuss about the relationship between the variables that involved in the interference, which is the lambda, the wavelength of the wave, and then we have A represents the distance between the two sources that we have, the two coherent sources that we have, and then we have X. X is always measured of the uh, distance between nodal line and antinodal line on the detector line, or if we use sound, it is the distance between loud and weak sound. And then if we use light sound, it is the distance between bright and dark fringe. And if we use water wave, it is from the strong wave and the weaker wave. So it is always represented by X. And then we have D. So D is the distance between the two sources. Remember we have two sources, and then it produce wave, and then we have the detector line where we detect the dark fringe, bright fringe, loud sound or weak sound. So this is the detector line, and the distance between the two sources and the point or the position where we want to detect the fringes and sounds. So it is represented by D. So we have all of these variables, lambda, A, X, and D, and can represent by this equation. Lambda, the wavelength, is always equals to the A times X divided by D. So what will happen if we change all of those variables? You can understand this one if you can understand your mathematics correctly. Change the subject of formula. If we want to investigate what will happen, let's say we want to investigate what will happen to the X. So this is the main formula, AX divided by D. Let's say we want to observe what will happen to X. So let's first make X as our subjects. So what do you need to do? You just need to arrange the equation, X as our subjects. So lambda D, you bring this side, division, divided, become multiplication, and then here A, from this side, we want to change the side to left hand side, it become division. So lambda D over A. So here you can see easily, you can determine easily the relationship between X and other variables. So A, lambda, D. So lambda and D, it is on the numerator of the quotient. It is on the upper part of the quotient. Here is the upper part or above the line. So X, lambda, D. So X is directly proportional to lambda, which means if X increase, this is the mean. If lambda increase, X will increase, or if lambda decrease, X will decrease too. So that is meant by directly proportional. What about D? X and D also directly proportional. So when D increase, lambda also increase. D decrease, what will happen to X? X will follow decreasing. So but for A, X is inversely proportional. As you can see here, A is the denominator of the quotient. It is on the lower part of the line. So it can be written as here, in terms of relationship. X is inversely proportional to A. So when A increase, what will happen to X? X will decrease. So X will go in opposite way as A. A increase, X decrease. And if A decrease, what will happen to X? X will increase. It will go differently in other direction. But for this one, directly proportional, it will follow accordingly to their original direction. Lambda increase, X increase. D decrease, X decrease. But for A, it will go in opposite way. That is how we can change the subject. let's say you want to observe what will happen to X. What will happen to? What do you need? Okay, what do you need to do? Okay, what need to be done if you want to change D? Okay, or what are the effect? Okay, maybe you can see what are the effect of D. So D equals to, so you want to make D as our subject. So D AX over lambda. Okay, AX over lambda. So that's mean this one increase, D must be increase. X increase, D also increase. But for lambda, since it is the denominator or the lower part of the quotient, so lambda decrease, D will increase. Okay, this one will go in opposite side. But what will happen if lambda increase? So D will increase. Okay, that is just mathematics. Okay, some mathematics in this chapter. Okay, this one you can observe the diagram. So as lambda increase, X increase. So where is X? You can see here the distance between the nodal or antinodal line. Okay, so if you draw a line here, the detector line here, so distance of the nodal antinodal, what will happen here? It will increase. The distance will increase. So X will increase. Lambda increase. Okay, where is lambda? You can see here lambda. Distance between crest and crest, trough and trough. Here is longer, right? So lambda increase, X will increase. And this one, it is shown to you that as A increase, okay, A increase, where is A? So here, distance between the two sources. So this one is shorter, this one is being increased, so longer. So as A increase, so this one A increase, what will happen to X? So we had discussed this, okay. A increase, what will happen to X? Okay, so mathematically from the equation, we can directly see that X will decrease, and also can be proven by this diagram what will happen to X. As you can see here, okay, this is the nodal or antinodal line. So this one is the line. Okay, you can see, right, the line here. So let's just draw a line or detector line. So the distance here, what will happen? Dark and dark, or bright and bright, or water wave. Okay, for water wave, what will happen distance here? It will decrease. It becomes smaller, right? If here is 2 cm, this one become maybe 1 cm. Okay, so you can prove it either by doing your experiment or just showing it by using the equation. Okay, let's try to solve one problem involving interference. Okay, let's me remove this one first. Okay, we just add another layer. Okay, so let's look at the example of number 3. Okay, example number 3. In an experiment to investigate the pattern interference of a water wave, the distance between two spherical dippers is 2.5 cm. Okay, the distance, you must understand here, the distance between the two spherical dippers. Okay, dippers here, okay, that means you put something, okay, maybe we can show this later in our lab. Okay, just a sphere ball, and then this is surface of water, and then it will vibrate touching the water and produce wave. So this one we call it as dipper. So we have two dippers. That means the two dippers will represent the sources of water wave. Okay, once it touch the water, it will produce sources with two coherent. Okay, two coherent sources. So the distance between the two sources is given as 2.5 centimeter. And the distance between the two consecutive nodal line, okay, once it produce wave, and then it will produce line, and at the detector line, okay, we can see antinodal line, okay, antinodal line. So distance between the two consecutive antinodal line, okay, we have 2, 1, 2, and the distance between them are 5 cm. Okay, 5 cm. What is the wavelength of the water wave? So they want us to find the wavelength of the water wave if when the distance from the two deepest to the point of measurement of 10 is 10 cm. Okay, so the distance from these sources to the point of measurement. Okay, this is the point of measurement, the distance where we want to measure this antinodal and nodal line. So it is given as 10 cm. So we have difference between the two sources, the length with distance between the two sources, distance between the sources and the detector line, and then distance between the nodal or antinodal lines. So we have 3 and we want to find 1 lambda. So we have this one is equals to A. Okay, remember A represent the distance between the two sources. This one represented by D, and this one is represented by x. So we have a x d, and we want to find a lambda. So as you can see here, we have 4 variables, and these variables can be found in only one equation, okay, which is lambda equals to ax divided by d. And then we want to find lambda, so we don't need to change the subject. We just take this equation and just substitute the number. So A equals to 2.5 cm, and then x equals to 5 cm, and then we have D equals to 10 cm. So use your calculator. Then you will get this one 2.5, this one is 4, so 5 divided by 4. So it is 5 divided by 4, so 1.25, right? Okay, maybe you can use your calculator later. Okay. So this is the wavelength. Okay, just remember in your physics paper, okay, don't use fraction. Please give your answer or convert your answer into decimal places, at least 2 decimal places. Is it correct? 1.25. Okay, maybe you can check it later. If it is 1.25, then just write 1.25 centimeter. Okay, 1.5 centimeter. So that is how we can solve problems involved in interference. Okay, let's look into another example. Okay, another example. So example number 2. Example number 4. So example number 4. In double slit interference, okay, here we want to use double slit. Double slit interference is used when we want to investigate the interference of light wave. Okay, normally one source of light wave, and then we put double slit. Okay, double slit. That is one you had used in your form 1, I think. Okay, so light passing through this slit only. So it just like we have 2 different sources of light. So the distance between the 2 double slit, okay, blue light, the distance between the screen and the double slit. So screen, we will put screen to detect the dark and bright fringe. So the distance between the screen and the 2 sources, okay, it is not measured from the lamp, because lamp is just to produce the light so that it will passing through the 2 slits. Then at that slits, or the slit will become the sources of the light wave itself. So here we have distance between screen and the light sources is equals to 1.2 meter, and slit separation is 2 times 4. So slit separation is the distance between the 2 slits. So we can write it as A equals to 2 times 10 to power of minus 4 meter. 6 successive bright fringe. Okay, 6. We have 6 successive. 1, 2, 3, 4, 5, and 6 bright fringe at distance 1.2. So the distance for the sixth successive is 1.2 times 10 to power minus 2 meter. So here we have meter, meter, and meter. Calculate the wavelength. So they want us to find the wavelength. So what are the equation involved? So simple, lambda equals to ax divided by d. So so what is our A? 2 times 10 to power of minus 4 meter. So since all of them are meter, we don't need to look at the unit because all of them have the same unit in meter. But if the units given in different units like centimeter, millimeter, then you need to change to all of them into meter. So this one, A times X. So what is X? So how to find X? So this is not X. Remember, X is the distance between bright and the next bright. So this one is X. Okay, this one is the distance between 1, 2, 3, 4, 5, 6. Okay, 6. So we have 1, 2, 3, 4, 5. We have 5 distance of 5x. So 5x equals to 1.2 times 10 to power minus 2. So x is exactly equals to, okay, you can take out your calculator. I have my calculator here. So just calculate that one. So we have 1.2, 1.2 times 10 to power of minus 2. So minus 2 divided by 5. Then what I get here is, so how to convert this one? Okay, so it is 2.4 times 10 to power minus 3. So 2.4 times 10 to power of minus 3, and then divide by d. So d is given here as 1.2. So what we will get here, okay, you can calculate using your calculator. Okay, times 2 times 10 to power of minus 4, and then divide by 1.2. So this is what I get from my calculation. Lambda equals to 4 times 10 to power of 10 minus 7 meter. Okay, so this is the wavelength. So quite small, right? Okay, it is quite small. If you want to change to micrometer, it will become 4 times 10 to power minus 1 micrometer. Okay, it is in micro. So this is how we can solve the question, okay, involving interference. And later on, okay, in our class, we will do the next example, okay, which is example number 5. I think that's all for this video, and thank you.